Good afternoon, class. We are looking at section 3.8, differentials and linear approximation. We've already looked at various tools and formulas for differentiation. Now we are going to look at an application of that. The synopsis is given here, but we'll go over the details in a moment. We have differentiation formulas such as basic formulas we've seen, the product rule, the quotient rule, the chain rule, exponential and logarithmic rules. Also, we have the logarithmic properties. I hope you're very comfortable with them. They help with logs and their derivatives. Differentials. So let's look at a couple of definitions. For y equals f of x, we define dx called the differential of x by dx equals delta x. So take a look at this function y equals f of x. This is y equals f of x. We pick a point P and it has coordinates x and f of x. And if we move to the right by a little bit, delta x, this distance along the x-axis is delta x identical to dx, this distance. And it gives us a new point Q with coordinates x plus delta x and f of x plus delta x. dy called the differential of y by dy equals f prime of dx. That's how we define dy. In other words, y prime or f prime of x is dy dx. Therefore, dy is the cross product f prime of x times dx. That is the definition. We can replace delta y by dy for a function f, which is a continuous and differentiable function with a small delta x if delta y is difficult to evaluate. And we have some formulas here, starting with f prime of x. I'm going to remind you what I did here, dy dx. Therefore, dy is f prime of x dx. So let's go over this graph to make some sense out of this. There are some formulas first. Delta y is f of x plus delta x minus f of x. This one is obvious. Let's discuss this one. So as we go from point P to point Q, P has coordinates x and f of x, Q has coordinates x plus delta x, f of x plus the delta x. And delta y is the change in y along the curve. So this distance, QC, that's f of x plus delta x. This distance, PD, is f of x. Delta y is QB, the difference between this and this. Needless to say, PD is equal to BC. So BC is equal to PD, it's equal to f of x. So delta y is this distance of BQ, which is precise. As we mentioned, f prime is dy dx. If we approximate it by delta y over delta x, then delta y is approximated by the product of f prime of x times delta x instead of f prime of x dx. Now let's discuss dy as far as the graph is concerned. So this is the function and this is the tangent line. So delta y represents the change in y along the curve. dy, take a look at dy, which is AB. dy equals AB is the change along the y-axis when it comes to the tangent line. Change in y along the tangent line. Therefore, so delta y is precisely that. If we move the negative f of x to the other side, gives rise to the second equation. So the first one gives rise to the second equation. F of x plus delta x is f of x plus delta y precisely. Since f prime is dy dx, dy is f prime of x dx. And so this delta y can be replaced by dy, and that gives us an approximation. Why would we do that? If it makes it easier for the sake of calculation. The next topic, linearization. What is linearization? Linearization refers to finding the tangent line at some point A. Do we have to memorize all of this? No, just remember the tangent line. Point slope, y minus y1 equals m times x minus x sub 1. So if I move the y sub 1 to the right, and now I'm going to call m f prime of a, x sub 1 a, y sub 1 f of a. And now I'm going to change y to L of x. Do you have to memorize this? No, just remember the point slope and it will work out. Let's look at a simple example. F of x is 4x cubed minus 3x. Y, or f of x is 4x cubed minus 3x. We are asked to come up with dy and delta y when x is 3, dx or delta x is 0.2. So first and foremost, anytime they ask you for dy, find f prime of x or dy dx. So what is f prime of x or dy dx? 12x squared minus 3. So what is dy? Just multiply this by dx. So dy by definition is the same thing, f prime of x times dx. So just multiply this by dx. The next step is elementary algebra. Plug in x equals 3, delta x or dx equals 0.2 and evaluate. Of course, you can evaluate it. This is 9 times 12 is 108 minus 3 is 105 times 0.2 is 21. It's a simple calculation. Now we want to calculate delta y, and delta y is precisely f of x plus delta x minus f of x. So x and delta x, they add up to 3.2. So we put it here, and of course 3 here. Now again, this is completely elementary algebra. Evaluate this function at 3.2. Also evaluate it at 3. So it's at 3.2, it's at 3. And subtract one from the other. And we get 22.472. Notice, this value, delta y, is close to this value, dy. Are they identical? No, but they're close. Now, dy was a tad easier to calculate. And why aren't they that close? Take a look at delta x. Delta x is 0.2, and that's way too large. If it was 0.1 or even 0.01, if it was 0.01, they would be almost identical. Could somebody read this, please? Anyone? Okay. The radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3 millimeters. Use differentials to find the approximate change in the area of a cross section of the vessel. The cross section is in the shape of a circle. And it looks like that with some radius to begin with. In this case is 1.4. It becomes smaller because that's what the drug does. It goes from 1.4 to 1.3. So this is the original radius R. And this is the new R. So that means 1.4, it's gone down to 1.3. And the difference between the two, this much, is dr. So what do we have? Given R is originally 1.4. dr is the difference between the two, but it's the new one minus the old one. So 1.3 minus 1.4 makes it negative 0.1. And that's the key. You have to pay attention to the sign. So negative 0.1. And of course, the same units, millimeters. And obviously, everybody knows the area of a circle is pi r squared. We want the approximate change in the area. That means we want dA. So here's the translation. R is 1.4. dr, or delta r, they're identical, is 1.3 minus 1.4 equals negative 0.1 millimeters. Area is pi r squared. That's a formula from geometry. We want to find dA. Now, think of this as, instead of y equals f of x, it's a equals pi r squared, which means r is the independent variable. So what do we need to do? We need to find the derivative of this function, a prime of r, which is dA dr, and that would be like dy dx. I want you to compare this to this. A prime of r is like f prime of x. dy dx is the same as dA dr, because the dependent variable is y, the independent variable is x here. The dependent variable is the A, or area, independent variable is r. And what is dA? The product of these two. What is dy? The product of these two. So I want you to compare to this line. So we are comparing it to this line to find dy, in this case, dA. So to find a prime of r, let's use a equals pi r squared and differentiate it. And to differentiate that, of course, pi is a number. R squared gives you 2r, so it becomes 2 pi r. And what is dA is the same thing times dr. And now look at your given. Just plug in r is the original r of 1.4, and dr is a negative 0.1. And by the way, whenever you're done, the units of dA and A are the same, because this is in millimeters, this is in millimeters. And so their product, 2 times 1.4 is 2.8, times 0.1 is 0.28. Keep the negative sign, and you get negative 0.28 pi millimeters squared. Now, we rather keep it as pi. You can always use a calculator, not 3.14, but rather a calculator which has a lot of decimals, and this is the approximation, negative 0.8796 millimeters squared if you stop with a few decimals. Now, can we find the exact answer? Is there any way to find the exact answer? Anybody? So this is an approximation. This is dy, in this case dA. What would be delta y? In this case, delta A. Anybody? How would you find delta A? The exact answer. Well, let's go back to the question. What are we looking for? We want to find the approximate change in the area. So what is the change? The shaded region, isn't it? So the area of the large one minus the small one, and make it negative, or the small one minus the large one. In each case is pi r squared. So pi times 1.3 squared is the area of the small one. Pi times 1.4 squared is the area of the large one. Shaded region is the difference between the two. Of course, the reason we negate that because it's shrinking, it's getting smaller. And I have factored that the pi times 1.3 squared minus 1.4 squared is this much. And take a look at this number, negative 0.27 pi millimeters squared compared to this one. Very close. Very close. So we can find the exact answer. Anybody want to read this question for us? All right. A bacterial colony has a population of P of t equals 20t over 10 plus t squared in millions t hours after a nutrient is introduced. Use differentials to approximate the change from t equals 2 to 2.4 hours. So the very first thing is what is given? T is 2. And the change in time, delta t or dt, is the change in time 2.4 minus 2. That's the first thing we should notice. So what is given? T is 2 hours. Dt or delta t is the difference between the two, which gives us 0.4 hours. That would be the difference between the two, known as delta t or dt. We're going to look at this one. F prime of x is dy dx. dy is f prime of x dx. Instead of f of x, we have p of t. So think about this again. So we have f of x first, and we get f prime of x. So we have p of t. That means given p of t, first we want to find p prime of t. F prime of x, p prime of t, which means f prime of x is dy dx, p prime of t is dp dt. So given p of t, we want to find p prime of t like f prime. F prime of x is dy dx, p prime of t is dp dt. We want to use the differential to approximate. Over here we want dy, over here we want dp, which is the product of these two. So compare and understand what you're looking for. So the very first thing is to differentiate this function, which requires a quotient rule. So you need f prime g minus g prime f over g squared, where the top is f, the bottom is g. So we want p prime of t or dp dt. The top gives you 20 times the bottom, minus the bottom gives you 2t times the top, which is 20t, and just write the bottom squared. So again, 20 times 10 plus t squared minus 2t times 20t, and over the bottom squared. Let's distribute, see what we get. 200 plus 20t squared minus 4dt squared. We combine these two. We get 200 minus 20t squared over the bottom squared, and dp is the same thing times dt. We are going to replace the t with 2, dt or delta t with 0.4. just in case. And this is 4. This is 80. So 200 minus 80. This is 4. I'm making this 14. So 200 minus 80 divided by 14 squared gives, and times 0.4, that gives us 0.245 millions. That's how we arrive at that. Which means, by the way, $245,000. So the approximation of the change from 2 to 2.4, we have this much increase in the population. Now, can we come up with the exact change? Delta y is f of x plus delta x minus f of x. We want delta p. We want delta p. That means f of x plus delta x becomes p over 2.4 minus f of x becomes a p of 2. So plug in 2.4, plug in 2. Their difference is 0.189, and that means 189,000. By the way, you may notice there's of course, discrepancy. There's a difference between the two. We are not claiming they are identical. We are claiming they are close. But why are they so sort of different? Take a look at delta dt or delta t. 0.4 is pretty large compared to what? Compared to t, which is 2. Okay, this number must be small compared to t, and you will see a huge difference. They will be extremely close when this number is very small compared to the choice of t. All right. Use differentials to approximate 51 squared. How do we use differentials to approximate? First, we need a function which represents that. First and foremost, all you have to do, read it. 51 squared. 51 squared. So what is f of x? X squared. Let's say it was 51 cubed. You would say f of x equals x cubed. So that's the function. And the next thing is to choose a number very close to 51 where we can easily square without a calculator. What number would that be? What is the closest number to 51 you can think of? You can square it in no time. What about 50? Because when you square it, it becomes 2,500. The closest number to 51 would be 50. And what is delta x or dx? Since we are letting x be 50, from 50 to 51, there is a difference of positive 1. In other words, 51 minus 50 equals 1. So we let x be 50. Why? Because the closest number to 51 we can easily square. And delta x is the difference of what we want and this one. It's important to know, let's say it was 52. Delta x would be positive 2. Let's say it's 49. I'm going to write that. 49. If that would be the choice, then delta x or dx would be -49 minus 15, -1. You got to consider the sign. I can't emphasize this enough. So what we want f of x plus delta x, and remember, we want to approximate it. And by the way, 51 squared is really not too bad. You can probably use even algebra 50 plus 1 squared. I remind you of that one also. Let me Okay, you remember this one, you could do 50 plus 1 squared. You square the first one, becomes 2500. You multiply it by 2 and times 1 is 100. And then 1 squared, and they add up to 26. Oh, so you can easily calculate it in your head. It's not a big deal. But we want to go with the differentials. And so what happens now, we want f of x plus delta x, and we want to approximate it with this, f of x plus dy. That's what we want to use. So the first thing is, what is dy? Well, let's find what's dy by finding f prime of x. Here's your f of x. So f prime of x, or dy dx, is 2x, right? We differentiate that. So what is dy? The same thing, times dx. Let's go back here. What is f of x? X squared. What is dy? 2x dx. And now it's time to plug in. What do we want? We want f of 50 plus 1. We want f of 51, which is 51 squared. That's what we want. Right? That's what we are looking for. So we use x squared. That means 50 squared plus 2 times 50 times dx, which is positive 1. And this is 2500. This is 100. They add up to 2600. As you can see, this is extremely close to 2601. Extremely close. Why is that? Because delta x, or dx, is pretty small when you compare it to x. When you compare it to x, that's a small number. That's why. Now, we can use linearization, which means we can use the tangent line. And you don't have to memorize the formula for the linearization. Just use the point slope, y minus y1 equals m times x minus x of 1. And you need two things. You need a pair. The pair, x is 50. So when you plug it in, so you want the tangent line to this function at this point, okay, at x. So 50, comma, when you plug in 2500, and the slope is 100. Why is the slope 100? We've already calculated f prime of x, everybody. We've already calculated this. If you replace the x with 50, you do get the slope of 100. So everything has been basically calculated for. Now you're going to plug in, which means y minus y1, y minus 2500, equals m, which means 100, times x minus x of 1, which is 50. So just plug it into this. This is 50. So we have 100x minus 5000. So we have 100x. We're going to distribute 100x minus 5000. We're going to add 2500, becomes minus 2500. So this has to move. And now what do we want? 51 squared. We want L of 51. You can evaluate it using this formula, 100 times 51 minus 2500. And you see you get exactly the same answer here. So linearization and differentials, they must give you the same answer. There's a slight difference in their approach, but ultimately they're the same. I hope everybody's okay with that. What about square root of 27? Well, again, we want a function and we want a number very close to it that we can easily calculate that. So the function is, all you have to do, read it. What are we looking for? Square root of 27. So f of x is square root of x. So what do we want? A number. What can you think of? The closest number to 27, you can take a root easily. Anybody? What would be the number? Closest number to 27? Anyone?
25.
25, because the square root of 25 is 5. And from 25 to 27, there is a difference of 2. So delta x of dx is 2. So first and foremost, your function is square root of x. And we want to choose a number x close to 27 for which the square root is easy to compute. And that would be 25 because we know square root of 25 is 5. And then from 25, we want to go to 27. So 27 minus 25 gives us the positive 2. Now, again, I want to make sure you understand that if, for the sake of argument, we are interested in square root of 24, we choose exactly the same thing. The difference is delta x will be 24 minus 25, which is negative 1. So pay attention to the sign, everybody. So we want f of x plus delta x, which is f of x plus dy. And since f of x is square root of x, we've done this many times before, but let me just quickly remind you. So we put x to the power of 1/2, and f prime is 1/2, x to the power of negative 1/2, which makes it 1/2 square root of x. So since we've done it many times, if you wrote it, that's fine. dy would be the same thing, times dx. dy would be the same thing, times dx. So right here, we're going to write f of x, which is square root of x, plus this expression. And now replace the x with 25 here and here, and the x with positive 2. So we want square root of 27, which means f of 27, which means f of 25 plus 2, which means x is 25 and delta x is 2. So plug in. As you know, this is 5. So is this one? We can cancel out these 2. We get 5 plus 1/5, which means 5 and 1/5, which means 5.2. All right. Now, if you use a calculator, class, you see it's extremely close. If you want to go with 1 decimal, becomes actually identical. Of course, normally we use many more decimals, but they're very close. Can we use the different method called linearization? And again, all of these formulas, just concentrate on this point slope formula. So first and foremost, what is your pair? What is your pair? X comma y. X is 25. What is y or f of 25? 5. So square root of that is 5. So the pair is 25 and then the square root of that, whatever the function says. What about m? Take a look at this formula. Take a look at this formula. M, replace the x with 25, and that gives you 1/10. So this is the pair, and this is the slope. Y minus y1 That means y minus 5 equals m 1 over 10. X minus x of 1, that means x minus 25. I'm going to assume you can distribute and then add and subtract whatever you want. So in other words, this is obviously 1 over 10 times x minus 25 over 10, 25 over 10 is 5 halves. Move the negative 5, make it positive 5 with negative 5 halves is 5 halves. So y or L of x, is 1 over 10 times x plus 5 halves. And now what do you want? Square root of 27, f of 27. So replace the x in here with 27, and you get to the same answer. I'll leave it for you to finish it. You get exactly the same answer, everyone. All right, anybody wants to read this one for us? Okay, not everybody at the same time. One student is good enough. If anybody want to help us,
I can do it.
please.
In a manufacturing process, ball bearing must be made with a radius of 0.6 millimeters with a maximum error of plus minus 0.015 millimeters. Use differentials to estimate the maximum error in the volume of the ball bearing.
Perfect. Thank you so much. So let's see what's happening. Okay. So we have the spherical shape, okay, for those ball bearings in between. And it has the volume of 4/3 pi r cubed. We should know that. The radius is 0.6. R is 0.6. Delta R or dr is plus minus 0.015 millimeters. And ultimately, we want to use the differentials to estimate the maximum error in the volume of the ball bearing. That means dV. So we have R equals 0.6 with the proper units. Delta R is plus minus 0.015 millimeters. And we should know this formula from geometry. And so what happens is that it's either larger or smaller. Larger if we add plus 0.15 to the radius. Smaller if we subtract 0.015 from the radius. So I want you to know how that means plus minus. So as long as it's a little bit larger or a little bit smaller, it'll work. And that is what we are referring to here. All right. Now, volume is 4/3 pi r cubed, and we need to find dV. So going back to this, f of x y or f of x, in this case, v or v of r, if you will, because r is the independent variable. So f prime of x is dy dx. So what we want here, because the independent variable is r, we want dv dr. And dv dr, we've done it before. Basically, it's 4/3 pi times, now differentiate, r cubed, 3r squared. So we want dv dr. 4/3 pi times 3r squared, and we can get rid of number 3. We end up with 4 pi r squared. This is dv dr. This is like dy dx. But we want dy, which is f prime of x times dx, or we want dv, which is 4 pi r squared times dr. So compare it to this. And now plug in r is 0.6, dr plus minus 0.015, plug in. You have to use a calculator at this point. Of course, we can calculate 0.6 squared. It's 0.36. And when we put it into a calculator with a pi, it's an exact answer. And again, approximation, please do not use 3.14 because pi is 3.14159 and it continues indefinitely. So the approximate change, if we want to estimate the change in the volume, it's either larger by this much or smaller by this much. That's the meaning of plus minus. Needless to say, we can calculate the exact answer by calculating the volume with 0.6 and then calculate the volume with 0.6 plus 0.15 and 0.6 minus 0.15. And you have to calculate the difference between both of them and V over 0.6, both of them. That is extremely important. All right, class.